In today's lesson, we are going to introduce you to an important operation on sets known as the Cartesian product of sets. This important operation allows us to visualize many of the mathematical relationships in 2 dimension and more using the Cartesian coordinate system. Let us begin with 2 sets A and B. Here we have a set A of 3 triangles, red, green and blue. Set B has 3 rhombuses, red, green and blue. If I take an element of set A and pair it with an element of set B, put them in brackets and separate them with a comma, they form what is called as an ordered pair. And collection of such ordered pairs that can be formed, and how many such ordered pairs that can be formed? With each red, I can have 3 colored rhombuses coming from the set B. With green triangle, I can have another 3 rhombuses. With blue triangle, another 3 rhombuses, and therefore, I have 9 such ordered pair. Once we put them all in a set, this collection is referred to as the Cartesian product of sets. We also represent this as A cross B. So, the Cartesian product of sets is nothing but collection of ordered pairs, where the first element of the ordered pair comes from set A and the second element comes from set B. And if you observe now, there are 9 elements coming in this collection. There were 3 in set A, 3 in set B. So, the number of elements in A cross B is same as the number of elements in set A times the number of elements in set B. Also, it is important to note that if I take the 2 elements from the set A and B each, then the pair that is formed, that is triangle comma rhombus, is not same as the ordered pair rhombus comma triangle, because it is now in the second case the first element coming from set B instead of set A, and therefore, A cross B is not same as B cross A, and that is where we now come up with our formal definition of Cartesian product. Given 2 non-empty sets A and B, the Cartesian product A cross B is the set of all ordered pairs of elements from A and B, and in another more technical form, we express A cross B as a set which is collection of ordered pairs A comma B, such that A belongs to the set A and B element comes from set B. So, this is kind of our set builder form representation of A cross B, and if you list all the elements and represent, it would become the roster form. Let us take a simple exercise. If A set has 0, minus 1, comma 2 and B consists of 2 elements minus 1 and 1, what would be A cross B? So, again as we suggested, you will list all ordered pairs such that the first element of this ordered pair comes from set A and the second element comes from set B. It is also important to look ahead and say, okay, A set has 3 elements, B has 2 elements, therefore, A cross B is going to have a collection of 6 elements. And if you go in an ordered way, you will be able to list all the 6 elements very comfortably, not missing out any one of them or repeating. So, here you see I have paired 0 with minus 1 and then 0 with the second element of the set B, that is 1. Similarly, minus 1 coming from set A is paired with minus 1 coming from set B, and then minus 1 is paired with 1 from set B. Similarly, you get the other 2 ordered pairs of this collection as 2 comma minus 1 and 2 comma 1. Let us take another simple exercise which will give you a fair idea of what we are dealing with. Here we have A cross A, 9 elements, among which 2 are known as -1, 0 and 0, 1. You are asked to find the set A and the remaining elements of A cross A. So, here we are talking about the relation of the set A with itself. That is also a very much a possibility. You do not have to have two different sets. You can take the Cartesian product of a set with itself. So, you will now take an element from set A, pair it with element of set A itself. In this case, it is given that set A cross A has 9 elements. So, how many elements does set A has? Surely, we are looking at number of elements in A multiplied with number of elements in A to be 9. Therefore, the number of elements in set A will be 3. Now, do you need any more guesses as to what would the number of elements and what would the elements be in the set A? 3 elements, and you have 2 ordered pairs given, -1, 0 and 0, 1. All, that is the first and the second element, are coming from the set A. So, what is set A equal to? Right. The set A is nothing but collection of -1, 0 and 1. And now, I think you will be very comfortably able to write the set A cross A and the other 7 elements that are missing here. I will leave that for you to try it out on your own. Now, we talked about Cartesian product of 2 sets. What if I have 3 sets and I am interested in their Cartesian product? That is, what would it be as A cross B cross C? Simple enough. Find A cross B, get another set, and then take the Cartesian product of that set with the set C. Same as saying, if I have a set A as in this representation with 2 elements triangles, set B has 3 elements rhombus, and set C is now collection of pentagons. How many elements? 4. So, to form the Cartesian product, what am I going to do? Take an element from set A, an element from set B and an element from set C, and we will put those 3 together in brackets separated with comma. Now, such an element that we have formed is now known as ordered triples. Instead of ordered pair, now I have 3 elements in it. So, it becomes an ordered triple. And ordered, the word ordered means there is an order in which they have been written. The first element comes from A, second from B, third from C. So, if I have this representation, then how many such elements can be formed? Looking at the situation that I had A with 2, B 3 and C 4 elements, the Cartesian product of A cross A, B and C, that is A cross B cross C, will have 2 into 3 into 4, that is 24 elements. And that is how one would represent Cartesian product of 3 sets. At the beginning of the lesson, I said that it is a very important concept. Now, what does this mean? What does A cross B mean and why is it important? Well, to understand this, it is significant to note that I can take the Cartesian product of the real number, the set of the real numbers, an infinite set with itself. And when we do that, what does it signify? What does it represent? Take a look at this. If I take R to be the set of real numbers and I find R cross R, that collection would represent nothing but set of all ordered pairs x comma y such that x belongs to real number and y also belongs to real number. And we know from your previous knowledge that this collection is nothing but collection of all points in the Cartesian system represented in the xy plane. And therefore, every Cartesian product can be represented, can be marked on the Cartesian system. And of course, we also read R cross R as R2. Similarly, if I take R cross R, that is R cross R, 3 times, Cartesian product of real numbers with itself 3 times, then I am listing out all the ordered triples, and they are nothing but representation of all points in space. And therefore, such representation is visualizing the concepts of 2 dimension and 3 dimension. And the credit for this goes to the French mathematician René Descartes, who is also known as the father of analytical geometry. And on his name, we have the system named as Cartesian coordinate system and Cartesian product, Cartesian geometry, as we are looking at. Here is a little exercise for you. Let A be the set 1, 2, B 1, 2, 4, C 4, 6 and D has 5, 6, 7. You are asked to verify that A cross B intersection C is same as A cross B intersection A cross C. It is a very simple exercise which starts by first finding left hand side and right hand side then, and show that these two are equal. To begin with, if you find B intersection C, it is a common element of the set B and C, which gives you the set with number 4. And so, set 1, 2, that is the set A cross 4 would give you 2 elements 1, 4 and 2, 4. Let us find what the right hand side will be. So, begin by finding A cross B. So, A has 2 elements, B has 3. So, A cross B is collection of 6 elements. Similarly, find A cross C. Do you see what the intersection of A cross B and A cross C is? Well, surely it is nothing but 1, 4 and 2, 4, and therefore, we have verified that A cross B intersection C is same as A cross B intersection A cross C. So, in a sense, the Cartesian product gets distributed over the intersection of 2 sets. Isn't that so? Here we have another problem for you. Set A has 1, 2 in it. Set B is collection of 3 and 4. You are asked to find A cross B. Now, that definitely is not a challenge now. So, when we look at A cross B, that has 4 elements in it, and what are the 4 elements? 1 paired with 3, 1 with 4, 2, 3, 2, 4. So, we are looking at these 4 elements. Now, the second part of the question is what is more interesting. How many subsets will A cross B have? So, in this case, you need to use a concept that you learned in the chapter on sets, the first chapter of grade 11. Here, A cross B has 4 elements. So, the number of subsets will be nothing but 2 to the power 4. So, 16 subsets. And if you are asked to list all the 16 subsets, carefully if you list them down in a slightly ordered manner, you will be able to find that you can start with a set A cross B itself with all the 4. Then you may write all the singletons, that is sets which have only 1 element, and there would be 4 such sets. Then write all the subsets which have 2 elements in it, and similarly sets which have 3 elements, and not to forget the empty set. The set which does not have any element is always a subset of every set. So, counting the set itself and then listing out all the other subsets, in total along with the empty set we have 16 subsets. Now, why is this interesting? If I take a sub collection, one of these subsets, and look at it a little closely, for example, here if I take R equal to 1, 4, 2, 3, it is definitely a subset of the collections of all the subsets of A cross B, also known as the power set, right. Power set is the collection of subsets of a given set. Now, what is interesting about this set R is that you can think of the relation, the association between the ordered paired elements Yes, do you see that 1 plus 4 is 5 and 2 plus 3 is also 5. So, I can express this set R, which is in the roster form right now, in the set builder form as R is equal to A comma B such that A plus B is equal to 5. And now this is what we would be investigating a little more closely under the topic of relations in our next lesson. So, stay tuned.